Hi, this is Kevin at the Virtual Planetarium at Raritan Valley Community College. Welcome to our weekly Star Talk. Today we're going to be talking about our sun, but specifically we're going to be talking about why days are longer in the summer. But before we do that, let's talk about our upcoming moon phases. We have first quarter moon on June 18th, then we have a full moon on June 24th, and then the last quarter moon on July 2nd. So like we mentioned last week, the sun is rising earlier and earlier every day. Right now it's rising just before 5:30 in the morning, and that is because we are quickly approaching the summer solstice on June 20th. Here we have the same website we saw last week, timeanddate.com. I'm going to put the link for it in the description. And it shows us the sunrise times right here. Then the second column shows us the sunset times. But more importantly, the third column right here shows us the length of daylight. And what we can see in this daylight column is that the days are getting longer and longer until we get to this June 20th date right here. And that's because this right here is the longest day of the year, the summer solstice. And the days are actually getting longer because the sun is getting higher and higher up in the sky. So let's see what that would look like. So right now we have our planetarium sky set up. We're going to be talking about 3 specific dates, and we're going to be seeing the sun move across the sky. The first date we're going to be looking at is December 20th. That is the winter solstice. The next day is going to be the spring equinox. And then the last day we're going to look at is the summer solstice, so the upcoming June 20th. Now, we're always told that the sun rises in the east and sets in the west, but that's not always exactly true. It does happen twice a year, but most of the year the sun is actually just south or just north of west when it rises. For the winter solstice, it's as far south as it can go, and here we're going to see that as the sun rises right now. And we're also going to see that it doesn't get that high up off the horizon. The sun stays really low in the sky during the winter solstice and during the winter months too. We can also count how many hours of daylight we have in December 21st, and we have 1, 2, 3, 4, 5, 6, 7, 8, and 9 hours of daylight. So that's why this is a very short day. Now if we move along to the spring equinox, the sun is actually going to rise directly on east, and it's going to be higher up in the sky. Now we see that it's going to move across, and it's going to set exactly on west as well. And if we count the daylight hours, we're going to see each one of these circles represents an hour. We're going to see that there's 12 circles right here. And now lastly, let's move on to our June 20th date, or the summer solstice. And we see that the sun is actually going to rise a little bit north of east. So it's going to be rising from right around here. So it's moving higher and higher up in the sky. And that means it spends more time in the sky. So when we end up counting these circles, it's actually up in the sky for 15 hours. So that's why this is the longest day of the year, because the sun is higher up in the sky, so it stays up for longer. Now, why does the sun move in the sky? Well, to do that, we're actually going to look at the Earth from outer space. So we're going to change this view right here to see what it looks like if we were looking at the Earth from outside. So the reason the sun is changing in the sky with the seasons is because the Earth is actually tilted. So the Earth's axis is off by about 23.5 degrees, and that's what causes the sun to be in a different place depending on the time of year. Alright, so here we see the Earth around the sun. This is the orbit the Earth takes around the sun, and then we see 4 dates. We have December 21st, which is the December solstice that we talked about, the first day we looked at last time. We have March 20th, which is the spring equinox, and then we have the summer solstice over here. And then we have the fall equinox back there too, but we're not going to talk about that. We also have 2 people standing here on top of the Earth. We have somebody on the northern hemisphere that's going to represent us, and then we have somebody in the southern hemisphere. Now in that first sun path we saw for December 21st, we noticed that the sun was really close to the horizon. And again, that happens because of the Earth's tilt right here. Because the Earth is tilted when you're standing in the northern hemisphere on December 21st, the sun is very close to the horizon right here. So we have a line right here representing the horizon, and a line here representing the zenith, which just means straight up. And we can see very easily that during the December months, the sun is very low and close to the horizon because of that tilt. Now we're going to move along to June 21st, which is the summer solstice that's coming up. But I want you to take a look at the Earth's axis right here and notice that the tilt is still facing in the same direction. And that's why we get the seasons, and that's why we get the days of different length. So right here again, we have the person in the northern hemisphere that represents us here in New Jersey, and then the person in the southern hemisphere. If we turn on our lines for the zenith and the horizon, we can see very easily that the sun is a lot closer to the zenith. It's a lot higher up in the sky, and it's very far away from the horizon right here. Now we saw that when we looked at the sun paths, because we saw that the sun was rising and going higher and higher up in the sky until it got to June 21st. So that's why the days get longer, because of the tilt in the Earth's axis. Thank you so much for joining us today. Hope you learned something new. If you have any questions for us, feel free to write them in the comments. We'll be happy to answer them for you. If you like this video, please be sure to let us know. And if you haven't done so yet, please follow our channel. We're going to be coming out with a new astronomy video every week. Thank you, and I hope you have a great week.